personal thoughts, thank yous, prayers, and concerns. Today is no different. We all fall short in what we do every day, but it brings us comfort to know you hear us when we need you. In your name we pray. Amen.
Man, you may be seated, kind of light and crowd. However, we have opportunity to have quite a few out there in webland. Apologize for a little bit of delay. We're doing this via satellite today. Chris is, man, he's talking so far beyond my skill set. I don't even know what he's doing. All I know is I might need a good astronaut suit to to deal with what else going on today. But I do want to welcome, and you can see it on the screen here. I think they can see at least me, maybe not everybody else, but Jane Roush, our district governor, is with us. Hi, Jane. Super to see you. Our district governor-elect, Tim Gibson. Good to see him. Welcome, guys. And we'll be introducing Kelly here in a little bit. And we also have live on Facebook, Patty Stringfellow at this point. And then as Ringmaster Ned would say, and all you parents and children at home. So we've got quite a bit going on today. So welcome to all of you. And it's going to be an interesting day. This obviously is a recorded event. We're very excited about being able to do this during Earth Day and Earth Week. And I am grateful, and I know I kind of put it on Chris a little bit last week, but I'll say again, because I have a bigger audience, we are very blessed as a club to have an IT guy like Chris who can make stuff happen. So I'm going to change his name to Rocket Man or something. I don't know. We'll come up with something. I had asked Kenny Hahn to join us. Do you see him in the hallway there? If not, I can catch him a little bit later. We have some exciting news that I wanted to share with everyone today. On the end of the table up here are 5 brand new emergency band pagers that you guys could take a look at. We'll show those folks online some here in a moment. We're going to take a quick picture and presentation, and we've already done that. We got a district grant and put some money with it that is giving them a little more ability to, on wider bands, to reach out and not have as well, communication is key. So, and that's what this is all about. So Kenny, come. We're gonna stay in front of the camera, that camera. And then we have another camera back there. If you want to grab one, Sue, would you come as well? We want Sue to hold one. And okay. This will be a picture taking moment. Cheese. Oh. Yeah. There we go. There we go.
You got it right. Yep.
Very good. So look, it's got to be pretty.
Hey, it's got to be pretty.
That's impossible.
Try again.
Thank you, Kenny.
Thank you.
Let us know how they work. They are already all programmed and ready to go. And we're real excited about that piece of it. So
these 5 will actually 4 of them will finish out everybody, and we'll have 1 extra.
all right, so we've now got the whole staff. I knew that you had been working on that. Well, that's good to know. It took us a little bit to make it happen. So that's very cool that now everyone will have one. They won't have to carry a couple radios, and this puts everybody on the same page. That's about as technical as I can get with that. So congratulations. You guys worked hard last year flipping burgers to make this happen. That's pretty much how that works out.
Exactly.
So thank you, Kenny.
All right,
I appreciate it. I know you got other things to do, but I wanted to make sure that
Nope, we're cool.
we took care of that.
Holler.
All right, thank you. So we always do this. So it's cheers to the club today. It's each one bring one and each one drink one. So cheers, grab your water, whatever you're doing, and cheers to hard work and pagers for the fire station. Very exciting, very exciting. So I'm going to get right into our program today. We have with us Kelly Burton. I'm going to try and read some of this. I am not going to read all of it, Kelly, because you make me tired. Very, very. And if you want it in its entirety, you'll have to find it on our page. I did put it in the email. One of the members texted me back and said, I don't think she'll ever be successful. I thought she don't have a chance at all. So I'm just going to kind of hit the very, if I can get my phone to load here, of course, I tried to switch pages and we've had some challenge here today. So please hold while I pull this back up again. Kelly, it's good to have you with us. We're in Rensselaer, Indiana. One of the things I want you to tell us right away, of course, is how far you traveled to get to our meeting today via the internet. That's always super interesting. So Kelly is the program director, the NSF Office of Polar Programs, Arctic Sciences and Antarctic Sciences. She's an associate research scientist with the Earth System Science Interdisciplinary Center. I like the acronyms because those are.
I know, I'm sorry. Should have just.
So I'm going to let her pick and choose what all she wants to share. That was just the first 6 lines and it just goes on and on, but it's a pleasure to have you here with us in Rensselaer and with you in the northern part of the Rotary District 6540. You're live. This will probably be seen by 1,000 or so on the norm. That's pretty much how it works. So not to put any pressure on you, but welcome. And take your time here and ask for questions in the end.
Hey, thank you so much. I just want to say that in part of that paragraph that you were reading, one of the things that's in there is I actually did my PhD at the University of Chicago, and I realize it's just over the border, but I feel like, you know, things in that region are similar to the things where you guys are, you know, weather patterns and things that you kind of worry about, especially as we roll up on Earth Day. I have a dual affiliation right now. I'm with the National Science Foundation Office of Polar Programs, working both Arctic and Antarctic sciences, and I have a role with NASA still. I do some research for them on a satellite mission. So what I thought I'd do is give you a really high-level overview of going to Antarctica, and then bring it down to a very personal scale and walk you through, you know, a little bit of what my project is. So I'm going to share my screen, and I hope. If I could get a thumbs up from anybody, perfect. Thank you very much, Jane. So I just want to talk to you about living and working in Antarctica and you know, shape some of your thinking as you go into Earth Day. I really like starting Antarctic presentations with this picture. I was born in 1971. This picture was taken in 1972. So this picture is inside a unit of time that I refer to as 1 Kelly. This picture, everyone's seen this picture before, and everyone focuses on Africa, but what I want to point out is this was one of the very first times that we got a really good whole continent look at Antarctica. Can you guys see my cursor in the bottom of the screen there? Perfect. All right. This is almost the entire continent of Antarctica. So this was our first sort of big, good look at the continent. And so what that does for me is it just reminds me that the science of looking at Antarctica is relatively new. And that's exciting because all the researchers that are looking at Antarctica and working in Antarctica, they're actually playing a really pivotal and critical role, a meaningful role, because this is such a new thing. Everyone thinks of Antarctica certainly as cold. Maybe if you see yourself, you know, standing out there on the ice sheet, you might just have an innate sense that it's windy. There's 2 other things. It's wicked dry. The air is super dry. And on this picture in the upper right, is kind of capturing that in a weird way. This is what we call the 22-degree halo, and it's associated with basically little snowflakes in the air column. It's not snowing, the snow is just being carried along in that sort of dry environment. You can't really see it in this picture, but the 3 o'clock and the 9 o'clock parts of this halo sometimes get super bright, and we call those sundogs. Sometimes you can see those in, say, like North Dakota. It's really dry and cold in North Dakota. You'll see them there too. And then down at the bottom, this is what we call a sun pillar. And every once in a while, you get duped to thinking that the sun is setting because it's such a bright spot out on the horizon. But all of this is sort of a function of the dryness of Antarctica. No one really appreciates as much. It's even dry way out on the coast. Antarctica is our biggest desert in the world. And then finally, the last thing that a lot of people don't always take into account is how high you are when you're in the center of the ice sheet. The South Pole in this is a cross section. In other words, if you just sort of cut right through the continent along this line here from A to B, this is A to B. The South Pole is right about where my cursor is roughly. It's a little bit off of that. But at the South Pole, you're actually 10,000 feet above sea level. And that, if you guys have all traveled out to the, Colorado or so, and you know how altitude might affect you, 10,000 feet is actually a big number, especially when you add in the dryness. So that's one thing I like to always remind people, that it's actually pretty high. Antarctica is protected. It's actually a model for the way things should be going across the planet. Basically, all of the continent, plus a lot of the water around the continent, south of 60 degrees in latitude, is protected by a treaty, and it has been since 1959. There were originally 12 signers to that treaty. Those 12 signers are the flags kind of in the center ring. And now I think there's something on the order of 50 or so countries that have signed on to the Antarctic Treaty. The treaty itself is really stripped down, which is probably one of the reasons why it has been so successful for so long. There's not a lot of detail to it. Basically, it just locks up the continent and the water around it for scientific research and no sort of exploitation for resources or for any sort of military gain. And you'll see cooperation down there between different countries. It's just, again, a model for the way the rest of the world should be operating, especially if someone's life is at risk. You'll see countries, literally move militaries to get those people back to where they need to be, to get the help they need. It's really a great example of just camaraderie and working together. It's fantastic. You can imagine one of the ways that we get there is via vessel, and this is pretty typical. I think in the upper left, that's a fuel tanker. Up, center top is just sort of our resupply vessel. All these big mill vans come down delivering. The vessel will come down once a year and deliver all the food and everything that you need for a whole calendar year. So it's a big event. And yes, we eat, 2-year-old cookies by the time they come out of their mill vans and get processed through the kitchen, but it is what it is, and you're happy to do so. In the upper right, the vessels get support from the US Coast Guard. That's a big old icebreaker, and the way that actually breaks the ice is it kind of accelerates up onto the sea ice and lets the weight of the vessel break through the sea ice. It's pretty impressive to watch. And then the US Antarctic Program operates 2 research vessels. In the lower right, there's a 20-year-old photo. As I was pulling into my archive last night and looking at different things, that is a 20-year-old photo of what the boat called the Nathaniel B. Palmer. It's kind of our big research vessel. And on the left, the Nathaniel B. Palmer is in the background, but a smaller research vessel called the Lawrence M. Gould is in the foreground. And the stuff that you can do on these boats is absolutely amazing. What we've kind of incorporated into it from an instrumentation and data analysis perspective. It's pretty impressive. Boats are pretty typical for getting to Antarctica and for getting anywhere, so that's not too atypical, but my gosh, some of the vehicles that we drive around in Antarctica are really weird. Top center, snowmobile. I'm sure a lot of people in the room are out on Facebook. You guys are running up to Michigan and going snowmobiling, so that's not too atypical. But look in the upper left, that's a snowmobile plus a pickup truck that has been fitted with basically triangular tracks. So instead of having tires, I think this is cool. It's called a mat track. These things go through a lot. It's kind of a modern update on this guy in the lower left, this Tucker, which also has, 4 different sort of articulated tracks. These things, the Tuckers go a little bit slower. That's fine. They chug along. In the lower right, we'll talk about these a little bit later because this is the vehicle that I use quite a bit. These are called piston bullies. And if anybody out there skis, these are the same type of vehicles that groom your skiways or your ski areas. Often they have a blade off the front. We don't need that in Antarctica. So we use them a little bit differently. In this case, we're using it for a traverse to drag some stuff across the ice sheet. And I'll show you some more detail on that later. In the upper right, I actually really like this vehicle. There's one driver, he sits up here, where they normally do in the front. But let's say that for whatever reason, he puts the cab of this vehicle, say, through the sea ice into the water. This rear vehicle has a drivetrain, and from that driver's seat, he can actually drive that rear vehicle, part of the vehicle, out of the backwards and hopefully pull the front of the vehicle out of the sea ice. So it's really cool. Like you just don't see that. We also have some wicked interesting aircraft. This guy in the lower right, this is not too atypical. It's just a big C-17, I believe. And there's wheels here, and the difference is it's landing on some sea ice, and that's pretty interesting. But just above it, I'm sure a lot of folks in the room are familiar with C-130s. It's kind of the old workhorse of the military. The difference with this guy is it's got skis on it. So this is a C-130 fitted with skis. It's called an LC-130. And these guys fly out of New York. The Air National Guard helps support our work on ice. Here's two more, the end members here are two more examples of planes on skis. This is an old Bassler fitted with skis, and this is a Twin Otter fitted with skis. And of course, we have some local helicopter operations going on. And just to give you a sense of it, here comes a Twin Otter landing on skis. And I groomed that skiway with one of the piston bullies that was out in the field. We needed some mechanical help, and these guys came and bailed us out. And even though it looks smooth, I hope you see the aircraft kind of bouncing around a little bit. That's a pretty rough landing. But those guys are good. And then this is what fuel delivery to the field looks like. They just roll out a big old 55-gallon drum, and you fill yourself up and you keep going. So it is unique for sure. Just getting fuel or flying around, it's all unique. It's beautiful. So on a typical year, we put about, the US Antarctic program puts about, which is operated by the National Science Foundation, they put about 120 or so different science projects in. Now those numbers are a little bit different the past 2 seasons. With COVID, we really had a very skeletal science plan. All sorts of issues with getting people quarantined and getting them safely on the ice and trying not to bring COVID to the 7th continent. In a typical year, again, prior to 2000, we'd have about 3,000 people traveling to the continent in the US program to 3 different stations, and I'll show you that in a minute. And again, the 2 research vessels as well. So here are the stations. So everyone thinks of, the South Pole. That's kind of the flagship sort of, because that's what folks think of when they think of Antarctica. But the big station is actually down here, McMurdo. It's south of New Zealand. And we'll get into some details on that in a minute. But basically, to get to the South Pole, you got to go through McMurdo. And that makes McMurdo a lot bigger than the other stations. From McMurdo, we can basically get to most of the parts of the continent without any trouble. We've got fuel caches out there to help us do that. And that's important when you think, the US does a pretty good job of responding to incidents that happen down there when somebody needs help. The US is one of the greatest countries that can get there and help people out and get them back to safety. And we've got Palmer Station, and it's much smaller. I'll give you some numbers on that in a minute. And it's right on the coast. It's at about 64 degrees south. Just to put that into reference, that's about as far south as Fairbanks, Alaska is north. So it's cold, but it's certainly not, off the hook cold. And it's right on the ocean, which helps it out. So getting there, the main National Science Foundation office is in Washington, D.C. Their main support contractor is in Denver. Most of us fly out of, California commercially to get down to Christchurch, New Zealand, where we have a facility that provides clothing and all sorts of stuff for folks that are getting ready to go to the ice with the getting ready to go to Antarctica with the US Antarctic program. Once you're in Christchurch and you have all your gear, you get on one of those military aircraft, maybe the C-17 if you're lucky, maybe a C-130 if you're less lucky, and that takes you to McMurdo, takes you to the edge of the continent where you get more stuff. You get the stuff you need to, say, go camping, or the stuff you need to, use to go into the deep field to do whatever you're doing. And then from there, you can take a flight to the South Pole, and that's obviously on one of those skiered aircraft for sure. The other option is to get to Palmer Station, and that's pretty similar. You fly commercially through Santiago down to Punta Arenas, Chile. And then from there, you usually get on a boat and take about a 3 to 5 day journey through the Drake Passage. And yeah, that can get exciting. It's fun, but exciting to Palmer Station. For the work that I've been doing recently, and I'll show you some slides associated with that in a couple of minutes, but I fly commercially to New Zealand. That's about 8,000 miles. I get miles for that because it's commercial. Then I get on the military aircraft, get to McMurdo, collect some stuff, and then fly to the South Pole, and I don't get any miles for those. And then to come home, you just reverse it off. Again, no miles for all the stuff on continent, but it is what it is. Here's the sort of flavor. I'm not going to read through this slide, but here's the flavor, the type of science that we support in Antarctica. And this is huge. I mean, all aspects of things that we do here in the US are actually, you know, things that are important to us in the US are covered in the sciences that we fund in Antarctica. Obviously, you know, Indiana's in kind of an interesting place because we talk a lot about sea level change, the melting of the ice sheets, and how important, you know, that is to especially our coastal communities. I'm on a satellite that you'll see. I'm on a satellite mission that you'll see in a second, associated with looking at changes in our polar regions, looking at changes in our ice sheets, but also changes in sea ice. Changes in sea ice are probably what have an impact on your day-to-day life in Indiana the most. Changes in sea ice have a huge influence on the exchange of heat from the ocean to the atmosphere. When you remove the sea ice, you actually allow that exchange to happen. And that governs our winds and our circulation at the pole. And that translates now not just to the coastal communities of the world, but to everybody. It has a huge impact on global weather patterns. And there's a little bit of sea ice science going on in Antarctica, more so in the Arctic because it is a bigger issue in the Arctic. But all I'm trying to get at is that the sciences that we do there are important to everybody, including, especially from a weather perspective, folks in Indiana. Actually, I should say really quickly, I'm most interested in sort of the earth sciences and the geodesy and the glaciology, and we'll get to that in a minute. So McMurdo, this is the big one. This is that station that supports basically the South Pole, and from McMurdo, there's a couple different airfield options that help you get to the rest of the continent. So that entire list that we just looked at, most of those folks come through Antarctica, come through McMurdo. You can see in this photo, this is taken from a hill over town, these little lined up buildings right here, these are our dorms. This sort of yellowish roof right here, that's our main galley. And this building right here on the left is the main science facility. So yeah, 1,000 beds. Sometimes that blows people's minds that it has that type of capacity. South Pole gets a little bit smaller, it's a little bit more remote. This has about 150 beds. And because of where it is, it's so quiet. It's from a sort of pollution sense. Ultimately, there's a lot of astrophysics and aeronomy going on down there. So this picture in the upper right is one of the many there's a handful of telescopes right now that are at South Pole. This is the current facility in the picture on the left, a big sort of modular thing. You can just barely see. It actually is up on stilts so that we can kind of keep it, the ice changes, and we'll get to that too. The stilts help kind of mitigate any sort of loss of the building from changes in the ice sheet. We can make adjustments to the stilts. And most people, when they think of the South Pole, maybe they think of some of those older images of the dome. In the back left corner, this lower right photo is the old dome that has been, since taken down since the construction of the new facility. So this is kind of a cool picture with both the stations in the same shot. That's me from like 2003, frozen. Palmer Station. Palmer's the little guy. There's only about 50 beds at Palmer. And because of where it is on the coastline and you access it by boat, a lot of the type of science that goes on at Palmer has to do with like organisms and ecosystems. It's gorgeous down there. These are cormorants up in the upper right corner. These little black dots that you see in this photo down here, these are all little Adelie penguins. And this guy's a big elephant seal. He stinks. I can tell you, I can almost smell that photo from right here. These pictures are a little bit dark because my only experience at Palmer was actually through some of the winter months. So this is when I arrived, when it was still nice, and then it just got darker and darker, there's a novelty to that. It's actually beautiful when that happens. Okay, so now I could give you a sampling of all the different sciences going on with just a picture associated with each, but what I thought I'd do instead is just sort of take you on, what my science is and make it a little bit more personal. I, again, have that dual affiliation, and I've been working with NASA on the ICESat-2 project. It actually is an acronym because it's NASA and it has to be an acronym, I think, but it's the Ice, Cloud, and Land Elevation Satellite 2. We had one that was called ICESat that was on on orbit between 2003 and 2009. And then it's a laser altimeter. It gave us a great insight into measuring the surface of our ice sheets, coming back again and measuring the surface of the ice sheet again and looking at the change. And it was deemed that, hey, we need a follow on to this mission. And so ISAT-2 was launched in 2018, and it's still active and operational. It's doing great. So again, it's just a laser altimeter. It's got an instrument on it that sends out a laser pulse. The pulse bounces off the surface, comes back up to the instrument and gets received. And the instrument knows the two-way travel time. That's what it's measuring, down and back. From that, from knowing the location of the satellite and translating that sort of two-way travel time and distance, we can actually get at the elevation of the ice sheet. And then we come back and we make a second measurement right at the same spot. And we use those two measurements to look at the change. How much did the ice sheet lose in that time period? And we're doing this at the centimeter scale. And I'll show you some of the work that I do to kind of show that we're doing this at the centimeter scale. And this is a big deal. You know, we're looking at Antarctica in a detailed resolution that we haven't been in the past. And so it got a lot of traction. This is actually a figure that came from an article that was written up in the New York Times after about our first full year of data being collected. And this is exciting. They do great graphics. That's their graphics, not mine. But we got a science paper out of sort of the first look at this. And that's a big deal. In my community, to have a paper published in science is actually a big deal. So I told you we're measuring this at the centimeter scale. How do we know that? That's where I come in. So these are the tracks that ISAT-2 surveys. And again, it's just in a repeated track type mode. So it samples almost 1,400 tracks, does a complete what we call cycle of those 1,400 tracks, and then it comes back and measures them right over those same tracks again. So those tracks all converge down here at the pole. We don't quite go over the pole. We get really close to it. We get to 88 degrees south and 88 degrees north. But you can see that all those tracks converge in that area. That's where the data are the most dense. And so we decided, I was in the room when it was decided. I really don't know how this happened, but we decided let's go drive a chunk of that line, dragging GPS instruments to collect ground-based data to compare against the satellite data. So the GPSs that are in your car don't just measure where you are on the road. They also measure actually how high you are relative to the center of the earth. It's just not information you need when you're navigating, so they don't publish it, right? So what we did was we used really high quality, what we call survey quality GPS instrumentation to measure the height of the ice sheet with the GPS. And then we use those GPS measurements and made direct comparisons against ISAT-2, against the satellite elevations. And so this is what we did. We flew down to McMurdo and then into the South Pole. And I hope you can see this really faint little pink triangle. This is that triangle right here. And we drove this, and we've done it 3 times already. I'm shocked at work the first time. No one was more surprised than I am. I'll show you some footage of the vehicles doing the traverse. And this is only 750 kilometers. You know, it takes you 2 weeks to drive it. I think my parents have a house at 750 kilometers from where I am in Baltimore. If I get up early in the morning, I can have lunch with them. So it's frustrating to me that this drive took 2 weeks, but it is what it is. It's an tracked vehicle. Specifically, this is the tracked vehicle. So this is how we traversed. So we drove these piston bullies, those same things that groom your ski area, and we dragged tents and equipment. The tents were set up. Those tents are what we actually sleep in. And we just drove the 750 kilometers. There's the sled that's there is just a very thin bit of plastic that actually has a really low friction coefficient. So it helps the sled, you know, slide a little bit easier than it normally would. And the last thing I want to point out from this before I move on is that little thing right there, that little disc, that's actually our antenna. That's the thing that's collecting the GPS data that we're going to use to compare against the satellite. But this is, I can't believe this worked. You shouldn't say that, but I can't believe this worked. It was exciting when we made it all the way around. It's horrible camping. It's cold. This is our sleep setup. I think we have, you know, each of us had about 2 or 3 thermarests or foam mats, followed by one big mummy bag, you know, a minus, made for about minus 40 degrees. And then that mummy bag was shoved into another sleeping bag that provided a little bit more insulation. In all honesty, it was very comfortable. And once I got in there, it took a little bit of time to get in there. But once I get in there, I loved it. It was that, you're snug as a bug in here. This is our eating quarters. You can see it's really tight. I can tell just from where this guy in the green shirt is sitting that he was cooking that night because he's closest to the stoves in this photo. But it's tight, it's not glorious. Everyone thinks, oh, the romantic, the adventurous, but this is what it really looks like. So yeah, I'll repeat that it was cold. It was about minus 15 degrees Fahrenheit without wind chill, but it was windy. One of the reasons why it gets so windy in Antarctica is that once the winds sort of start, they're gravity driven, and there's very little mountains to provide any sort of friction or anything to the winds moving forward. So they just pick up speed, and that's when it gets exciting. And it's dry, as I stated. It's the world's largest desert. The whole time that we were on traverse, we were over 10,000 feet. So the South Pole Station was actually the lowest part of our traverse. And it's bright. In this particular case, you want to do it when the vehicles are going to be happy. And so you're at the height of summer, which is actually December and January, because it's the flip of our season. And then, of course, this is, another one of those 22-degree halos. It's marginally brighter out here where the sundogs would be, and very bright down here at the sun pillar. And this is it. This is the only graph. Don't worry. This is the only graph. I'm going to show you what we did. So what you're looking at here is dates on the lower axis. So about 2018, when we started satellite operations, out to fairly recently. And on this axis, what you're looking at is the offset between the GPS data and the elevation data. So you want it to be down at this red line. And we're not there. We're a little bit above. If you just squint your eye, you'll see that most of the mass of those data are just above that red line, that 0. That means that our satellite is measuring it a little bit higher than it's supposed to. And we understand why. As we then make our ice sheet products, we make changes to that. So this is very informative for us and ideal for getting information to higher level data products out to the science communities. I just want to point out one other thing. We did this traverse in 2018, 2019, and early 2020. And then obviously the pandemic hit. We haven't been able to do it in 21 or early 22. And that's okay. So it forced us to think about our data a little bit differently. So we had 3 years of data to look at. And what we did was the line that we're really interested in is out here. It's at this 88 south, going from A to A prime. And this is from A. This is now height. So that's this yellow part of the graph here indicates higher elevations. So from A to A prime, you go over a mound, and that mound is only 100 meters. It's not very big, over 300 kilometers. It's not very big at all. But then out here, there's a flat section. And when we compared all 3 years of data together, what we realized was there's a lot more variability on the mound side than on the flat side. And so what we've been doing more recently is only making the comparisons out on this side, on the right side, on the flat side, because our data are now 2 years old, and we know that there's variability from year to year on this left side. So in my mind, this is one way that scientists are working to get through the pandemic, think about their data differently, and find ways, solutions to still do their science with an understanding that you can't always get to where you need to go because of global limitations. So this is, in my mind, somewhat of a little bit of a success story, and it might change the way we do the next traverse, which is cool. And the last thing I want to leave you with is just a good understanding of it. The ice sheet itself is it's not static, it's moving. And so what this map is showing you is the velocity of the ice sheet at any point on the continent. So ice flows much like maple syrup would if you poured it into the center of your pancake. It flows out very slowly, especially if it's cold, right? Cold syrup is going to flow slowly towards the edge of your pancake. Warm syrup flows faster. What you're seeing here, this sort of red shade is the slowest velocity. And this sort of very purpley, extreme purple over here is the very fast sections of the ice sheet. So from the high parts of the ice sheet out to the coast, and then, to the very edge of the ice sheets, it starts to pick up speed. But it's the whole take home is it's moving. It's not static. It's all part of the normal process. We keep adding snow in, and then things flow out towards the edge, and we add snow in and flows out towards the edge. But it's flowing even at the South Pole. So this is the cool part. You ready? Every year at the South Pole, every new year, surveyors come out and they mark exactly where the South Pole is. In other words, if you've got a point and you have ice flowing, where you actually mark the South Pole with a pin moves from year to year. And in this case, I think it moves 30 meters a year. I might be a little high, but I think it's about that. So you put a pin in one year, and the next year it's 30 meters away from where the geographic South Pole actually is. So they come in every year, put a new pin into the South Pole where it should be, and they put a marker on it. A benchmark is what we call these in surveying terms. And the benchmarks get designed by the former winter over crew. So they put a lot of time and effort into designing these benchmarks. So the new benchmark comes out, there's a whole ceremony. They put the pin in where it's supposed to be. It's 30 meters away from last year's marker. And ultimately they pull that marker off, the old marker, they pull it off the stake and they bring it inside. And that's what this display case is all of the South Pole benchmarks over the past handful of years. And some of them go back to, the mid 80s, which is kind of nice. And there's a couple missing here and there, but I think it's a really cool ceremony that they do and a special thing. But it also reminds you that, and my summary statements are just here, the ice sheet is dynamic. It's also changing, especially at the coast. That New York Times figure that I showed you, all the color to that figure was around the coastlines where our ice sheet is in contact with both our warming atmosphere and our warming ocean. So it's important to understand these ice sheets and how they are changing. And NSF and the U.S. Antarctic Program are facilitating that type of science and other sciences. I know I focused on this one, but again, because it's near and dear to me and hopefully give you a more personal account of going to Antarctica. That's the last slide I had. I'd be more than willing to take questions, or if people are now groggy from their lunch, I understand that too. But I thank you for your attention.
Thank you, Kelly. Yes, applause. I see applause online. I really appreciate you being here. You are absolutely correct. I do go south in the wintertime. I will never go that far south. I promise you that is not happening. When I saw the minus 15, I went, nope. Northwest Indiana is plenty cold for me. But I do appreciate
I understand.
and information, and I know we have contact information. Chris has provided us with that. It's in our emails, and again, just very appreciative of what you're doing. And I'm going to use the word sacrifice.
We do have a question online, though.
Okay, we have a question from online. Go ahead.
Is it true that the food situation is very good, but a little unusual?
Asking about food. What? I'm not sure.
Yeah, so the food that we eat there, keep in mind, let's go to McMurdo, right? I told you there's 1,000 beds. So they've got it looks like a dining hall in college, but it looks like a dining hall from like the 80s. I feel like the food in dining halls got better sometime in the 90s and whatnot. They're really limited, by the fresh foods that they can get there. And they do amazing things with, generally not so fresh material. They also, because it's so cold, people burn calories in the cold. And so they like to, get a lot of bang for their buck in the proteins and whatnot that they provide. I'm overly impressed by what comes out of the galley. And I will say the other thing, I'm pretty happy about it because someone else is making it and someone else is cleaning it up. I'm not going to lie. It doesn't get too unusual as far as, we're not eating anything, out of the local area because that's against the treaty. That would be a treaty violation. Everything that we eat is shipped in and then the waste is shipped out.
Cool. So maybe I do need to go to the South Pole and burn some calories. So maybe that's That's
It's good.
ultimately the secret. Thank you again.
Thank
I'm sure
you.
there'll be some follow-up, and you're welcome to stay online with us. Just got few things here we're gonna roll through. I want to give a quick report from the weekend with our Empowering Girls initiative that we held this last weekend at the fairgrounds. I believe the final registration was 28 girls. Did have a couple that weren't able to show up at the last minute, but I will read this from Terry, who wasn't able to be here and organize it. Said, "I will let you know that it was a total success. The speakers were awesome. The parents, most of them stayed. And as they left, they told us that it was a wonderful, very positive experience for their daughters, and they enjoyed it very much. 2 dads were even there too, which I thought was very interesting. We did have some people not show up, so we're going to figure out how to do that and get some stuff to them, even though they registered. So that's a feather in our cap a little bit there, Jane. Just saying, wanted to make sure that you heard all that. We're excited about what that was about. We'll get more pictures posted and get our reports filled out and all those kind of things. So it was a very, very successful event. Also, Sue is continuing to work on the color guard for fire department here. So far, we have raised about $1,100. We need close to $1,900 to finish this out. So if you want to continue to donate to that, that would be awesome. Every little bit will count. And we're hoping to have that together and then have the Boy Scouts and the volunteer fire department present that to us when we get it all here and get it together. It's ordered and on its way. So we're looking for help with that. Again, I want to remind everyone for next week, the high school top 20 will be here. This means that we'll have 2 weeks in a row meetings. We will not be at Fenwick's next week, so make sure that you help spread the word. We will be here for the top 20. And then the following week, we will also have some special speakers as we move then into May. And so we've got 3 good lunches in a row. That's the way I look at it. So make sure that you meet with us here at Tuesday at noon. District conference is coming up. Steal Chris's thunder a little bit. Go with me to Notre Dame. We'll go out on the field, get our pictures taken, have a tour, have a very beautiful banquet in the evening on Friday. It will be worth your drive and your time to go. And of course, there's all kinds of district meetings that you can get involved with. I'm kind of excited about it. I'm not going to lie, even though I struggle. Don't tell Jane or anybody that's out that way. I struggle with Notre Dame, but that's a whole sports conversation that we'll just leave alone. I know those are fans. So we're pretty excited about that coming up. Make sure you get registered online. Always check your email. We've got a lot of information in there. So I think that covers pretty much everything. I appreciate everybody that joined in online. We'll make sure we get attendance for all of that. And I thank you guys for being here today. Let's stand for the 4-way test. I'm going to hold the fellowship and the 50-50 till next week. For those of you who have money in that we're going to let that ride. So if you've got a ticket, it'll be in there next week. Stand with me for the 4-way test. Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned? Have a good afternoon, everybody.